This is our video to present our Simio May 2019 student competition where we simulated a supermarket distribution center. This is Group 1 and the participants are Luisa Gomez, John Hatchett, and Grant Skidmore. The outline of this video is as follows. 1. Major model components. 2. Model assumptions. 3. Functional elements and behaviors. 4. Physical architecture. 5. Logical architecture. And 6. Experimentation and performance metrics. Our 3 major model components are delivery, unloading, and put away. To briefly describe each component, we can say that the delivery is a network of paths that are leading to our docks. Our unloading is where we set up receivers to process the shipments that are coming in. And our put away operators and RPJs are putting shipments into specific aisles. We came up with the following assumptions for this project. Assumption number 1, the shipments are being carried by the delivery trucks. Assumption number 2, the shipment is separated into pallets at the separators. Assumption 3, all trucks can travel on any path within their network. Assumption number 4, there's an infinite amount of vehicles. Assumption number 5, all workers arrive and leave on time and are equally efficient. Our first functional element and behavior is the generation of the arrivals and the modeling of shipments. Here we created a pivot table in Excel to get the inner arrival times between shipments and put that into Simio as a rate table.
Here we have a rate table that we created to put into our entity arrival logic for our source along 7 days of the distributions.
The PDF and CDF graphs of our distribution are shown on this slide. Next comes our processing arrivals, which is breaking shipments into pallets. Our source here is producing pallets to go into separators, where receivers will then break them into shipments. As far as assigning pallets to a relevant aisle using a random uniform distribution, we did this with add-on process triggers, in which we have the PAOs taking the pallets to their sinks using a discrete distribution. Later in the video, we'll show how this was programmed into our model. For scheduling the workers, we went under data and work schedules and we set up 2 different shifts for the workers. With the information provided as far as the simulation cost, we have a usage cost per hour for the put-away operators and the receivers. Then we have a one-time capital cost for our RPJs. Our separator member output add-on process is as follows. As soon as the entity arrives at the separator, it receives an assigned statement giving it a value of the random discrete distribution, followed by a set node step that references a table of sinks for docks 1 through 35. For docks 36 to 46, the entity gets a set node step that will reference a table of drop-off areas for the RPJs. Next, we're going to go into our physical architecture in our Simio file. Here we're going to explain our entities, our vehicles and workers, our pathways, separators, sources and sinks, and networks.
In our Simio file, we have many entities doing the different jobs that we have for our distribution center. The first one that we're going to start out with is the receivers, which process at the separators, which are our docks. We have 2 set up with an additional capacity of 2 per shift. They only travel on the workers network and they travel at 3 miles per hour, the average speed of a human, and their initial home is at the member output dock of each dock. Then we go to the put away operators, and those are the people who pick up the shipments after they've been processed by the receivers at the output of the separator, and they as well walk at 3 miles per hour and have an initial capacity per shift of 4. Again, the put away operators and the receivers both get a pay of $29 per hour. And then we go to our RPJ, which is a robotic pallet jack that has a speed of 5 miles per hour and an initial home of the drop-off point 1 of the RPJ, and has an initial ride capacity of 2.5 pallets, a initial capital cost of $150,000 with two on shift, two RPJs per shift. Then we have a pallet, which is our shipment that we have going to our aisles. Our delivery truck itself is the one that takes the certain amount of pallets and takes it to their respective aisle numbers. The delivery truck can hold up to 5, and the number of pallets that we have for our delivery truck is dependent on the discrete distribution set aside for the state variable at the output of the source 1. So we're going to go ahead and run our simulation and increase the speed, not quite that much. And we're going to go through our simulation, how we set it up, and the different processes of the logic. So at our source, we have a generated pallets, and with the rate table that we provided in Excel. And then on these specific 4 different pathways here, we have a network of roads in which our delivery trucks are able to travel on. And then once we go down to the end of the roads where the receivers will be picked up, or the receivers will take the shipments and take them to the separators. We make copies of the pallets according to the number of pallets distribution that we have. And then the process time is based on the number of pallets times the random triangular distribution that was provided to us in the problem statement. As well, we have the receivers as a secondary source for our separators for 1 through 46. And then whenever we go down to the output of each node, we have a different story going in which the RPJs have to pick them up. Or from 36 to 46, excuse me, we have the RPJs picking them up and going to 2 different spots according to a random discrete distribution. For docks 36 through 46, we have different logic, and which they're being picked up by RPJs and being taken to 2 different locations throughout the map, one being drop-off point 1 and the other being drop-off point 2. Let's go ahead and look at the process of the output source for those different docks. And right here we have a decision if it is a pallet or not, assigning it a random discrete 1 or 2 drop-off point, and which is referencing a table that I made of just the 2 drop-off nodes. Those are the only docks that are being picked up by the RPJs and then taken to the specific nodes, the RP drop-off points. Dock 1 through 35, however, are being processed by put-away operators once the separator takes and makes them into pallets that need to be going to different aisles. And let's go ahead and look at the process logic for that. We just first off decided just exactly like the process of dock 36 through 46 if it is a pallet or not, and then goes into the random discrete distribution of aisle numbers 1 through 30. And after that, we have the set node to reference that random discrete distribution and go along with the table that I made of the input of the aisles. After the RPJs drop them off at the drop locations, we have another set of process to be picked up by the RPJ put-away operators and take them to an aisle number. So let's go ahead and look at that. After at drop-off point 1 and 2, we have the checking if it is a pallet or not again. And then going for the random discrete distribution, exactly like the assign statement for doc 1 through 35, and then going to the set node exactly like doc 1 through 35. Now, networks. In the whole entire Simio project, we have 3 different sets of networks, one being the roads in which the delivery trucks and shipment trucks carry the pallets. So that's 1, 2, 3, 4, 5, 6, 7, 8 right here. And then the receivers network, and that's all the networks past the major roads and leading up to the separators. Workers. And then after the separators did their job, receivers did their job and go to the put away operators, everything past that, including the aisles, are included on another network for the warehouse, including RPJs are allowed to travel along these. I think that's it.
That's it? Go ahead and cut.
Here is a 30-day run of our Simio file. We can tell that the pallet was produced by the source 9,016 times, and then destroyed or sent to a specific aisle 8,550 times. With the vehicle, we can tell that the utilization was 80.8%, and the put away operators shift 1, sub 1, was utilized at 95.5%, and put away operator shift 1 sub 2 was utilized at 94.0%, followed by shift 1 sub 3 put away operator utilized at 94.5%, and put away operator shift 1 sub 4 was utilized at 92.6%. We can see that it's variance because of the closest setting that we have. So whenever a separator is done being processed, the put away operator comes, the first person that's closest comes and picks it up. So for put away operator shift 2 sub 1, we can see that its utilization was 39.7%, and put away operator shift 2 sub 2 was utilized at 38.9%. Shift 2 sub 3 was used at 36.5%, and shift 2 sub 4 was used at 33.5%. Our receivers were total cost of $6,123 and utilized at 95.9% for shift 1 sub 1, and shift 1 sub 2 was utilized at 96.1% and costing us $6,007. Shift 2 receiver 1 was utilized at 99.9% and cost us $6,246. And receiver 2 shift 2 was utilized at 99.6% and total cost is $6,221. The RPJ was utilized at 44.2% and was an initial cost of $150,000. We can see that it wasn't utilized as much because it only worked on docks 36 through 46.